Welcome to another exciting episode of Exploring the Universe. In 2006, a controversial decision shook the astronomical world. After 76 years as our solar system's ninth planet, Pluto was suddenly demoted. This dramatic reclassification sparked heated debates among scientists and space enthusiasts alike. But what if I told you that far from diminishing Pluto's significance, this change opened up an entirely new and fascinating chapter in our understanding of the solar system? Hey everyone! Today, we're diving deep into one of modern astronomy's most captivating topics, dwarf planets. These mysterious celestial bodies have completely transformed our traditional view of the solar system. From the icy plains of Pluto to the intriguing surface of Ceres, we're about to embark on a journey that will challenge everything you thought you knew about our cosmic neighborhood. These remarkable objects exist in a class of their own, telling us incredible stories about the formation and evolution of our solar system. Before we venture further into this astronomical adventure, make sure to hit that like button and subscribe to Exploring the Universe. By joining our community, you'll never miss out on fascinating space content like this. Plus, don't forget to turn on notifications by clicking the bell icon. Did you know that the story of dwarf planets has led to the discovery of hundreds of new objects in our solar system? Today, we'll uncover why these celestial bodies are far more significant than their dwarf designation might suggest. Get ready to explore a universe where traditional definitions are challenged and new discoveries await around every orbital path. Let's delve into the fascinating world of dwarf planets and explore what makes them unique members of our solar system family. The International Astronomical Union, the global authority in astronomy, established precise criteria for defining these celestial bodies in their historic 2006 resolution. This decision fundamentally changed our understanding of the solar system's structure and classification. A dwarf planet, according to the IAU's official definition, exists in a fascinating middle ground between planets and smaller solar system objects. To qualify as a dwarf planet, an object must meet three specific criteria that tell us a remarkable story about its physical nature and orbital dynamics. First, these bodies must orbit the Sun directly, just like the 8 recognized planets. This distinguishes them from moons, which orbit other planets, and helps us understand their independent role in our solar system's architecture. This direct solar orbit shows that these objects are significant enough to maintain their own paths through space. The second criterion is particularly intriguing. Dwarf planets must have sufficient mass to achieve hydrostatic equilibrium. In simpler terms, this means they're massive enough for their own gravity to pull them into a nearly spherical shape. This is a remarkable characteristic that sets them apart from irregular asteroids and comets. When an object reaches this state, it means its internal forces have become strong enough to overcome the rigid structure of its rocky components. A fascinating threshold in celestial body evolution. However, the third criterion is what truly defines a dwarf planet and sparked the most controversy. These objects have not cleared their orbital neighborhood. Unlike the 8 major planets, which have either absorbed, ejected, or gravitationally dominated nearby objects in their orbital paths, dwarf planets share their orbital space with numerous other bodies. This is why Pluto, for instance, coexists with many other objects in the Kuiper Belt, unlike Earth, which dominates its orbital zone. This inability to clear their orbital paths tells us something profound about these objects' formation and evolution. It suggests they emerged in regions of the solar system where there was too much material for any single body to become gravitationally dominant, or where orbital dynamics prevented such dominance from occurring. This characteristic has led to the discovery of numerous potential dwarf planets in the outer solar system, each telling its own story about our cosmic neighborhood's complex history. These criteria create a unique category of celestial objects that help us better understand the diverse population of bodies in our solar system, from the smallest asteroids to the largest planets, with dwarf planets occupying a crucial middle ground that continues to fascinate astronomers and space enthusiasts alike. Let me tell you the captivating story of Pluto's discovery and its controversial journey from planet to dwarf planet. In 1930, a young astronomer named Clyde Tombaugh made history at the Lowell Observatory in Arizona. After months of meticulously comparing photographic plates of the night sky, he spotted a faint moving object in the distant reaches of our solar system. This discovery fulfilled Percival Lowell's prediction of a planet X influencing Uranus's orbit, though we now know this was coincidental. For the next 76 years, Pluto held its status as our solar system's ninth planet, capturing public imagination as a mysterious frozen world at the edge of our cosmic neighborhood. Scientists and textbooks worldwide acknowledged it as the smallest and most distant planet, with its highly elliptical orbit and unusual tilt, making it a fascinating subject of study. However, the 1990s brought a revolution in our understanding of the outer solar system. Astronomers began discovering numerous large objects in the Kuiper Belt, many similar in size to Pluto. The most dramatic discovery came in 2005 with Eris, an object even more massive than Pluto. This finding forced astronomers to confront a challenging question. If Pluto was a planet, shouldn't these other objects be classified as planets too? The International Astronomical Union faced a crucial decision in 2006. Either accept potentially dozens of new planets or establish clearer criteria for planetary status. Their historic resolution created the new category of dwarf planets, leading to Pluto's reclassification. This change wasn't a demotion, but rather a recognition of Pluto's true nature as one of the largest members of the fascinating Kuiper Belt population. The reclassification proved scientifically necessary because it helped us better understand our solar system's structure and evolution. Far from diminishing Pluto's importance, this change elevated it to a new role, the forerunner of a whole class of distant worlds that tell us remarkable stories about our solar system's formation and development. Let me tell you about Ceres, the pioneering member of our dwarf planet family. Located in the asteroid belt between Mars and Jupiter, Ceres was discovered on January 1, 1801, by Giuseppe Piazzi at the Palermo Astronomical Observatory. Initially classified as a planet, then an asteroid, Ceres finally found its true classification as our solar system's first recognized dwarf planet. Ceres is a fascinating world of contrasts. At roughly 940 kilometers in diameter, it makes up about a quarter of the asteroid belt's total mass. Unlike its rocky neighbors, Ceres possesses some remarkably planet-like features. Its spherical shape, achieved through its own gravity, hints at a differentiated interior with a rocky core and an icy mantle. Perhaps most intriguingly, scientists believe Ceres harbors a substantial amount of water, more fresh water than Earth has. NASA's Dawn mission, which visited Ceres from 2015 to 2018, revolutionized our understanding of this unique world. The spacecraft revealed bright spots in Haumea crater, composed of sodium carbonate, the largest deposit of carbonate minerals found beyond Earth. These deposits suggest recent geological activity and potential subsurface briny reservoirs. Dawn also discovered organic compounds on Ceres's surface, raising intriguing questions about the possibility of primitive life ingredients in the asteroid belt. One of Dawn's most exciting discoveries was evidence of cryovolcanism, ice volcanoes that once erupted water and minerals instead of molten rock. This activity suggests Ceres might still be geologically active today, making it a much more dynamic world than previously thought. If you're enjoying this deep dive into the fascinating world of dwarf planets, don't forget to hit that like button, and I'd love to hear from you in the comments. Which dwarf planet captures your imagination the most, and why? Is it Ceres with its mysterious bright spots, or perhaps another member of this intriguing family? Share your thoughts below. Haumea stands out as one of the most peculiar objects in our solar system. Shaped like an egg due to its rapid rotation, completing one spin every 4 hours, this dwarf planet stretches about 1,430 kilometers at its longest point. Its unusual shape comes from its incredible rotational speed, making it the fastest spinning large object known in our solar system. Adding to its uniqueness, Haumea possesses 2 moons, Haumea and Makemake, and is surrounded by a ring system, making it the only known dwarf planet with rings. Makemake, named after the creation deity of the Rapa Nui people of Easter Island, is slightly smaller than Pluto, but still one of the largest objects discovered in the outer solar system. Its surface is covered in frozen methane, ethane, and nitrogen, giving it a reddish-brown color. Unlike its dwarf planet siblings, Makemake appears to be devoid of any significant atmosphere, making it a pristine window into the early solar system's composition. Recent observations have revealed that this frozen world might harbor at least 1 moon, though our knowledge of its satellite system remains limited. Eris truly revolutionized planetary science. Its discovery in 2005 ultimately led to the redefinition of what constitutes a planet. Slightly more massive than Pluto, though slightly smaller in volume, Eris orbits the Sun at an average distance nearly 3 times that of Pluto. Its surface is covered in frozen nitrogen, similar to Pluto, but appears even brighter due to its more recent frost coating. Eris's discovery challenged our understanding of the solar system's architecture and forced astronomers to reconsider how we classify celestial bodies. Each of these dwarf planets continues to reveal new surprises as our technology and observational capabilities improve, demonstrating that our solar system still holds many mysteries waiting to be unraveled. Ceres harbors an extraordinary secret beneath its cratered surface. Evidence suggests the presence of liquid water. The Dawn mission revealed that despite the dwarf planet's location in the asteroid belt, subsurface brine reservoirs may exist, particularly beneath the Kuiper crater. These reservoirs could maintain liquid water through a combination of dissolved salts and remnant heat from the dwarf planet's formation, making Ceres a potential candidate for primitive forms of life. Pluto's system of moons is remarkably complex. Its largest moon, Charon, is so massive relative to Pluto that astronomers consider them a binary system. They orbit around a point in space between them. 4 smaller moons, Nix, Hydra, Kerberos, and Styx, dance in chaotic orbits around this pair. The New Horizons mission revealed these moons tumbling unpredictably through space, challenging our understanding of orbital dynamics. The nitrogen ice on Pluto's surface creates otherworldly landscapes, unlike anything else in our solar system. In the heart-shaped region known as Tombor Regio, nitrogen ice flows like glaciers on Earth, creating vast plains and intricate geological features. This ice sublimes and reforms with Pluto's seasons, effectively creating a nitrogen-based weather cycle that reshapes the dwarf planet's surface over time. Haumea's rotation is a scientific marvel. Spinning once every 4 hours, it's the fastest rotating large body in our solar system. This rapid spin literally pulled the dwarf planet into an elongated ellipsoid shape, creating what appears to be a cosmic egg tumbling through space. The discovery of a ring system around this already unusual object in 2017 added another layer of complexity to this fascinating world. The study of dwarf planets has fundamentally transformed our understanding of the solar system's architecture and evolution. These objects reveal that our cosmic neighborhood is far more complex and dynamic than previously thought. Rather than a simple 8 or 9 planet system, we now recognize a rich diversity of worlds occupying distinct orbital regions, each telling its own story about our solar system's formation. The presence and characteristics of dwarf planets provide crucial insights into planetary formation theories. Their diverse compositions, from the water-rich Ceres to the methane-covered Makemake, demonstrate how location and initial conditions during the solar system's formation influenced their development. Their orbital patterns, particularly in the Kuiper Belt, preserve evidence of early solar system dynamics, including possible migrations of the giant planets. Current estimates suggest there could be hundreds of undiscovered dwarf planets lurking in the outer solar system. The most intriguing candidates lie in the region beyond Neptune, where objects like Sedna hint at the existence of many more distant worlds. Advanced survey telescopes, like the upcoming Vera C. Rubin Observatory, are expected to reveal dozens of new dwarf planet candidates, potentially including some larger than Pluto in the far reaches of our solar system. These discoveries continue to reshape our understanding of planetary systems, suggesting that the transition from asteroids to planets is more gradual than once believed. Each new dwarf planet discovery helps us better understand not only our own solar system, but also provides insights into the diversity of planetary systems we're discovering around other stars. NASA's New Horizons mission made history in 2015 with the first-ever close flyby of Pluto. The spacecraft revealed a surprisingly active world with mountains of water ice, glaciers of nitrogen, and a thin atmosphere. New Horizons captured stunning images of Pluto's heart-shaped region, Tombor Regio, and discovered evidence of cryovolcanoes, dune fields, and ancient liquid nitrogen lakes. The Dawn mission, active from 2007 to 2018, was the first spacecraft to visit two dwarf planets, Ceres and Vesta. At Ceres, Dawn discovered bright spots of sodium carbonate in Okata crater, suggesting recent geological activity. The mission revealed evidence of subsurface water, organic compounds, and possible cryovolcanism, transforming our understanding of dwarf planet geology. Several future missions are under consideration. NASA's proposed Persephone mission would return to Pluto for a longer-term study, potentially orbiting the dwarf planet to study its seasonal changes and complex moon system. The European Space Agency is considering a mission to explore Ceres's potential for hosting primitive life forms. Additionally, concepts for missions to other dwarf planets like Eris and Haumea are being developed, though they face significant technical challenges due to the extreme distances involved. These missions are crucial for understanding not just dwarf planets, but also the formation and evolution of our entire solar system, as well as the potential for life in unexpected places. As we conclude our journey through the fascinating realm of dwarf planets, we find ourselves at a profound realization. Our understanding of the cosmos is not static, but constantly evolving. The story of dwarf planets perfectly illustrates how scientific classifications and our comprehension of the universe continue to grow and change with each new discovery. What was once a simple narrative of 9 planets has transformed into a rich tapestry of diverse worlds, each with its own unique characteristics and stories to tell. The reclassification of Pluto and the recognition of dwarf planets hasn't diminished our solar system. Quite the opposite. It has revealed a more complex, more interesting cosmic neighborhood than we ever imagined. From Ceres's potential subsurface oceans to Pluto's nitrogen glaciers, from Haumea's rapid rotation to Eris's bright frozen surface, each dwarf planet contributes to our understanding of how planetary systems form and evolve. These celestial bodies challenge our preconceptions and remind us that nature doesn't always fit into neat, simple categories. The boundary between what constitutes a planet, dwarf planet, or other celestial object is more nuanced than we once thought. This realization has profound implications not just for our solar system, but for our understanding of the countless planetary systems we're discovering around other stars. As our technology advances and new missions explore these distant worlds, we can expect even more surprises and revelations. The dwarf planets we know today may be just the beginning, Hundreds more could be waiting to be discovered in the outer reaches of our solar system, each potentially holding new clues about our cosmic origins and evolution. Before we end this fascinating journey through the world of dwarf planets, I want to thank you for joining me in exploring these remarkable celestial bodies. If you've enjoyed this cosmic adventure and want to stay updated with more fascinating space content, make sure to subscribe to Exploring the Universe and hit that notification bell. Your support helps us continue bringing you these amazing stories from across the cosmos. Don't forget to leave a like, share this video with fellow space enthusiasts, and follow us on social media for daily doses of astronomical wonder. Until our next cosmic journey, keep looking up and wondering about the mysteries that await us in the vast expanse of space.